Hey folks, so this is the notebook for Investigation 2, Week 1, Stream Table. And this week we're studying what are some processes that form landforms and change Earth's surface. So we're going to be talking about how landforms are shaped by slow processes over time, such as weathering, erosion, and deposition. And we're demonstrating how rocks can be weathered into sediments by a number of processes. And the frost wedging, abrasion, chemical weathering, and root wedging, we'll talk more about that next week. In this investigation, we learn about processes that have shaped the earth around us over time. As we study the forces of weathering, erosion, and deposition, we'll be able to tell the story of how some of the most incredible natural features on Earth, like the Grand Canyon, were formed. And there will be a project which is called Modeling Rock Layers Project. Okay, so scrolling down. Deposition in a basin. What is a basin? Well, I asked students to really look at this picture. It kind of looks like a boring little pond or a lake, but think about how it slopes down and how when it rains, material will drain down. And when material drains down, you're going to have things piling up in this basin. Over time, you'll have lots of layers piled up in this basin. And that's exactly how new rock layers form. It's from lots and lots of material piling up in a basin over time. So basins are really important when you're thinking about how do rocks form. Basins are part of the puzzle that is very important to know about. And thinking a little bit about the Grand Canyon and that giant canyon, where did all that material deposit to? And so we were talking about how we think that the material would have deposited into a basin, maybe the ocean. And today, when we look at the picture of the Colorado Plateau, we see that it would deposit in Lake Mead, which is the lake that formed the beginning of the Hoover Dam. So if you look at this picture, let's see if we can see it. You can't actually see Lake Mead on this picture. You just see this big plateau, which is called the Colorado Plateau, and then the Colorado River carves into it. But basically, that river will continue until it hits a basin, and then all that sediment that got carved out of the canyon will deposit somewhere. And so it would deposit in a basin as well. We're just not sure which basin it is. Probably Lake Mead. Okay, then we created a model of a basin because, we can't all travel to Lake Mead. So we did a model of a basin. We watched this video. We recorded observations while we were watching and showed how the different layers of sediment piled up on top of each other. So we just listed which sediments we saw deposit into this basin. So this would be layer 1. Layer 2. Layer 3. And this would be like if a bunch of sea creatures died and their bodies got buried under some sediment. And eventually this would form limestone, right? Because that's made out of dead sea creatures. Here's some white sand. So eventually that might form sandstone. Here's a layer that looks like volcanic rock. So we can think about, what if an eruption happened? Then there would be a layer of volcanic rock in the basin. And a few more layers on top. We've got another layer of sand. Kind of fills in all the cracks. And then whatever this substance is floats and makes the water super murky. So in class we talked about how that's probably a very fine sediment, maybe clay or ash, something that would float and be a very small particle size. So then we've recorded our observations here, and we labeled the types of sediments in all the layers. And we even drew a picture of it by double-clicking on the basin and adding layer upon layer of lines. We used scribble lines. So mostly they're all scribble lines. So if you click on line and go to scribble, then you can make a line. That's a pretty ugly line. And you can change the color of it, and you can make it thick if you want, make it thicker. And that's how we did that. And we also added a text box. Okay, but these are things we've practiced a few times before. Okay, save and close when you're done. And then we predicted, what do we think would happen to the sediments in the basin over time? We thought that the sediments might break down or they might compact together. The water might become more clear as the sediments settle. The clamshell fossils might turn into limestone. And there might be new and different layers of rocks that form. Then we started talking about, okay, well, a lot of this was sand, so eventually down the line it would make sandstone. And so we thought, all right, well, if it's a chicken or the egg situation, what comes first, sand or sandstone? And so we thought about that and we made a prediction. We said blank came first because. And so you can think about what you think should come first. Does sand come before sandstone? Is sand required to make sandstone? Or is sandstone required to make sand? So think about that and then write your prediction down there. We talked about how we might make sand. We said we could break rocks, grind pebbles, use a chisel, smash rocks against other rocks, hammer time, all kinds of different things. We watched a video which showed us a method for making sand. So you should watch that video too. Observe and record the results of sand making. You can watch that and then record your observations. And we did this definition for abrasion by looking at the glossary. We clicked on the glossary and we found the definition for abrasion and we copied it into our notebook. We just Control-C'd it right in. It's right here. It's this first one. So you can Control-C it right into your notebook. And it's when rocks hit and break other rocks. And so that's really what's going on in that video. When she's shaking up the rocks, she's seeing the rocks get abraded, which is the same kind of thing you would do with a rock tumbler if you wanted to make nice, smooth, polished rocks. And after all that, what we realized was you could make sand with any type of rock. And so we wrote, sand has to come first because you need sand to make sandstone, but you don't need sandstone to make sand. You could make sand with any type of rock that you smash together. Okay, then we said, okay, well, picture your life as a rock. What would that actually be like? What happens when you fall from a cliff? What happens next to you in your journey? And so I wrote this story. Your story should be different, but I wrote this story. So Fred landed in a river, Fred is the rock, and smashed into a million pieces. Fred's pieces continued to smash and smooth as he traveled down the river. Eventually, Fred was sand. He retired in a nice, calm basin community, and he cemented with all his friends. They lived happily ever after as a nice layer of sandstone. The end. Okay, the final step was to look at this image of sand particles. Oh, this is not the final step, sorry. This was the second to last step. Look at sand particles and observe how is this sand from location A at the very top of the mountain different from this sand, which has traveled way down the mountain, way down the river, and here. And how is that different from the beach sand that has traveled even farther and ends up on the beach? And just noticing how those different sand samples are different and how they change. Okay, we said they get smaller, rounder, and better sorted. And finally, the stream table, the model of the Colorado Plateau. First, we got our definitions by using this glossary. Once again, just copied and pasted the definitions in. Then we watched this video, or we did the actual stream table in person. And we're looking for landforms. Where is it slow? Where is it fast? Where are the small sediments? Where are the large sediments? And the landforms that I see obviously are a river, a canyon, a delta. Where is it slow and where is it fast? Well, let's look. It's slow down here, which we could call maybe like the ocean or a lake. Here, let me pause it. No. It's fast when it's traveling down this stream. And then where are the big sediments and where are the small sediments? Well, the clay that you see here in the water, that's what's small. The clay mixes with the water and it travels all the way down to the end of the basin. The sand, if you can see it right here, it doesn't move as far as the clay does. The clay is totally mixed into this water. The sand only moves a little bit, sort of slopes downward. So those are the things you're meant to notice when you observe this. And what happens when the water slows down? We can see lots of sediments in the water. It's very murky. And those sediments eventually will deposit and sink once that water really slows down. Okay? Send me an email if you need any help with the notebook. And I will see you all next week.